Hello everyone, welcome back to Pre-Algebra with Miss Betsy. In this chapter we're continuing our discussion of how to deal with fractions, or what we call rational numbers. Today's lecture we're going to be working with word problems that involve fractions. If you're using the same text that I am in Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. This is the first edition that they've used. And today I am in section 7.4 on page 227. So feel free to come along and see what you can learn with me, even if you're not using that same textbook. But before we begin, my lame riddle for the day is, what does a rabbit use to comb her fur? Well, she uses a hairbrush. So I've already written 4 sentences up here on the board, because as we begin to get more involved in solving word problems, sometimes it can be a little bit scary because it's a new thing to us. We're not exactly sure what we're trying to find, how we can pick relevant information out of a problem, and then go ahead and actually convert from English into an algebraic expression. So what they've done is they've come up with just 4 steps here that they're very straightforward, but it will help you, I think, maybe a little bit to understand better how to deal with these word problems. First thing that you're going to do, of course, is make sure that you read your word problem, that you read it the entire way through. Don't stop halfway through. Don't read the first sentence. Don't stop when you have 2 or 3 words left at the end. You've got to read everything so that you understand exactly what information they're giving to you, so that you see what information in there is irrelevant, and also so that you understand exactly what they want you to find. Once you've done that, you're going to represent the unknown number with a variable. I use x all the time because I'm just used to using x, but a lot of people like to use a letter that might apply to what you're looking for. For example, if you're looking for the number of students in a room, some people will use S. If they want to know this, the number of days until something happens, they might use D. Doesn't matter what variable you use, obviously, because it's just a representation for an unknown quantity that we're trying to find, because in these word problems, that's all we're dealing with, is unknowns. They're saying, okay, I want you to figure out for me, if these conditions are true, what is this answer going to result in? What's the number of cars, the number of cats, the amount of money, the percentage of interest? It's something that we don't know, and that's all that we're using our variable for. Second step that we want to do is we have to learn how to represent other conditions in the problem in terms of the very same variable that we have picked up here in step 1. And I think this is maybe one of the things that is the most challenging for us to do as we begin to work with algebra and solving word problems. For example, let's say that we have a problem and it says there are 25 students in Mr. Jones' class. There are 5 more boys than there are girls. How many girls, how many boys are in the class? Well, there are 5 more girls than there are boys. So let's have B equal the number of boys. And you see, I just used B. Let's have B be the number of boys after I've just finished telling you that I usually use X. I did the B just for you. Our problem says we have 25 students in the class. There are 5 more girls than there are boys. So we've said, let's have B be the number of boys. So let's say that he had 2 boys in the class. How many girls is he going to have? Well, he has 5 more girls, so that would, 5 more girls, so that would give us 7 girls in the class. If we have 10 boys in the class, he would have 15 girls in the class. If we have 1 boy in the class, he would have 6 girls in the class. So what we're saying is that no matter how many boys he has in the class, the number of girls that he has is 5 more than that. And this is what we're talking about in step 2 here, where it says represent other conditions in the problem in terms of that very same variable that we used up here. So back to my problem that I made up off the top of my head. There are 25 students in the class. He has 5 more girls than he has boys. Find out how many girls, how many boys. Well, if B is the number of boys, I just showed you that if we wanted to find out the number of girls, we would take the number of boys, however many it is, which is B, and we would add 5 to that. And that's always going to give us the number of girls. And this is what this second step means right here. Represent other conditions in the problem in terms of this variable. Well, the first condition of the problem was this many boys. The second condition that we're going to represent here is how many girls. And this right here, B plus 5, is what they mean when they say in terms of that variable. That means, okay, in terms of their variable, in light of the fact that I know that B is going to represent the number of boys I have, if I take that variable and add 5 to it, that's how I come up with the number of girls. So that's what they're talking about when they say first pick your unknown, define what your variable is going to represent. Secondly, look in your problem and see, are there other conditions in that problem that I have to incorporate in my algebraic equation, and usually there are going to be. At this level there will be another condition. Well, you have to come up with an expression that will help you find that other condition, but you're going to use the same variable that you already used up here. You can solve equations by using more than one variable in certain situations. This is not one where we're going to do it. And we don't expect you to do that in pre-algebra. We do expect you to be able to say, to express one condition in terms of another, which is exactly what we're doing here. Second thing, apparently I had my hand on the board. Second condition says, identify what is equal in the problem. Okay, what is equal in the problem? Well, I said that the number of girls was 5 more than the number of boys, and the total number of students in Mr. Jones' class is 25. So what's going to be equal? Well, think about this. The number of boys plus the number of girls is equal to what? The total number of students. In Mr. Jones' class. And coming up with this, identify what is equal, this is a real key step in being able to come up with an equation. You have to figure out, this is what I'm looking for, or this is a total quantity that I've been giving. What can I put on the other side of the equation that represents the same value so I can do it? And here, number of boys, number of girls, total number of students in the class. Once we have this piece of information down here, you have to know what you're looking for, you have to know what is equal. Then, and only then, can we go ahead and write and solve the equation, because we now have something in English that we want to translate into algebra. What's our number of boys? We said let B be the number of boys. What's the number of girls? B plus 5 is the number of girls. What did I say in the problem was the total number of students? Yeah, I said that he had 25 students in his class. So here we have an equation that we can solve. We enclosed B plus 5 in parentheses because that goes together. When we solve this equation, 2b plus 5 is 25. We subtract 5 from both sides of the equation. 2b is equal to 20. Now we're going to divide both sides of this equation by 2, and we find that b is equal to 10. And you can be so accustomed to just solving an equation for one variable that you think, oh, I'm finished. Well, are we finished? No. Our problem that I created said how many boys and how many girls. What does B mean? Okay, B means that there are 10 boys. It's the number of boys. So our answer, we have 10 boys. And how many girls do we have? B plus 5 is the number of girls. So we have 15 girls. This is our solution. Now how can we verify that this is right? Well, this other piece of information over here said that when we added the number of boys, the number of girls, we end up with the total number of students. And we were told in our word problem that there are 25 students. Is 10 plus 15 25? Well, yeah, of course it is. So we know that we have solved our problem correctly. Now what I have here was just a step through using a very, very basic, no fractions, nothing in particularly difficult about this problem, but an example where I went through and showed you exactly what these 4 steps are talking about. And usually, or quite frequently, you're going to be able to have our variable be representative of what we're looking for, but sometimes you have to manipulate it a little bit differently. So let's go ahead and do the next example we have, and this one is going to involve fractions. In this example that they have in your book, I want to make sure that I step through it with you. But it's a little bit more involved than a lot of them are going to be. So don't be discouraged by it. It's early in the morning and I'm enjoying my coffee. Okay, I am now on page 228. Most of the time you represent the unknown number that a problem asks of you with a variable. Sometimes you must represent another unknown in the problem with a variable. Let's see what they're talking about. You might want to follow along with me if you have your book. If you don't, just pay attention to what I'm reading and you can still learn. The Junior High Drama Club performed the school play on Friday and Saturday nights. Attendance at the Saturday night performance was 1 1/4 times the attendance on Friday. If there were 95 people in attendance on Saturday, what was the total attendance for both performances? Okay, so you look at that, and that's a lengthy problem, and they've got a lot of numbers in there, and your mind can sort of do like the old pinball machines, which sometimes you can still find them and play them. You shake it wrong, and it goes tilt, and you can't work. Your brain can sort of want to go tilt when you have so much information here. So let's go back and read it again and analyze and see what we have. Junior High Drama Club performed the school play on Friday and Saturday nights. Okay, we've got 2 nights that the play is going on. So we have Friday night, and we have Saturday night. Okay, simple, straightforward, beginning to collect information here. Attendance at the Saturday night performance was 1 1/4 times the attendance on Friday night. So which has the larger performance, Friday night or Saturday night? Well, Saturday night has the bigger performance because it's 1 1/4 times the performance on Friday. So it's bigger attendance, or greater attendance, I guess. So it's 1 1/4 times Friday's attendance. attendance, not attendance. Now, it says if there were 95 people in attendance on Saturday, 95 people on Saturday, what was the total attendance for both performances? Okay? So we want to find total attendance. So we don't know how many people attended on Friday night, do we? So if we don't know how many people attended on Friday night, and we don't know the total attendance, then there's no way that we can use a problem like we did last time. Last time we had boys plus girls was equal to the total number of students, and we could say, okay, the girls was 5 more than the boys, so we had enough pieces of information to put that the number of boys plus the number of girls was equal to the total number of students in attendance. You would automatically think, or you'll learn when you're doing these types of problems, that your brain is probably going to immediately default to, okay, this is one of those sum total problems, so I'm going to put the number on Friday plus the number on Saturday is equal to the total number. But we really don't have enough information, because we could say Friday, don't have a value for Friday, don't have a value for the total. So we're going to have to look and see what we can do a little bit differently. So let's consider some more. What are we going to use for our variable? Well, it makes sense, since we are missing a piece of information here for Friday, doesn't it make sense that that would be our variable? Let's go ahead and put our unknown be Friday, because we know we need to have that piece of information. So what can we do? Let's just come up with an attendance variable, okay? I'm going to go ahead and follow their example in the book of using f. And let's just say, let f be equal to the attendance on Friday. Can we agree that that's reasonable? We don't know how many people were there Friday. We'll just let that be our unknown that we're looking for, and we'll say F. That just represents the total attendance that we have on Friday. Now Saturday, we know it's got a larger attendance, and we know that it tells us right here is the key piece of information. Okay? What we've done over here was we went through our first step. We said, assign a variable to represent the unknown, right? That was in our first example. We used B as our unknown, and that was the number of boys. The second statement said, use that same variable to represent the other unknown conditions in the problem. So we've got another unknown condition, don't we? We don't know what the attendance on Saturday was either, but we do know that it is 1.5 and 1.25 times Friday's attendance. So if Friday's attendance is F, then 1.25 times F would be the attendance on Saturday. So that's a very nice key piece of information that we have. So we're going to now say, let 1 1/4 F equal the attendance on Saturday. Very straightforward. F is Friday's attendance. 1 1/4 times F is Saturday's attendance. So now we have used a variable to represent an unknown, represented other conditions in our problem in terms of that same variable, 1 1/4 F. Now we want to see what can we say is equal to one another. Identify what's equal in the problem. Well, the only numbers that we've been given here is that Saturday's attendance is equal to 95. Saturday number is equal to 95. Can we come up with an algebra sentence, algebraic sentence that represents this here? Sure. What is the attendance on Saturday? It's 1 1/4 F. Now, I went ahead and said let 1 1/4 F represent the attendance on Saturday, but remember I said we don't want to use mixed numbers. So I'm going to go ahead and convert this into an improper fraction, which is 5/4, 5/4. And we now have a statement where one quantity, the attendance on Saturday, where we're using a variable to represent an unknown, where that is equal to the numerical number, the actual total attendance that we had on Saturday. Now we have one quantity equal to another, and now we can go ahead and solve this equation. This is a very straightforward equation to share now, to solve now, because we've learned, well, I don't care about 5/4 of F, I don't care about 25F, I don't care about -2F. I only want to find out what F all by itself is, or what 1F is equal to, because that gives me Friday's attendance. And we learned that if you took a number and multiplied it by its reciprocal, you always ended up with 1. And in layman's terms, reciprocals are when you take one fraction, turn it on its head. Set it upside down. 3/4 times the reciprocal of 4/3 is always going to be equal to 1. Any number multiplied by its reciprocal is always 1 because your common factors cancel out. So what's going to be the reciprocal of 5/4? Turn it on its head. 4/5 times 5/4. And what we do to one side of the equation, we have to do to the other side of the equation as well. And now we have 1F on this side. Our 4's cancel, and our 5's cancel, and we have F is equal to 95 times 4/5. We can cancel a common factor of 5 and see that we have 19 times 5 is 95. So when we cancel out a common factor of 5, we're left with 19 times 4. Now what do we need to do? Can't reduce anything else. We multiply our numerators together, and we end up with the attendance on Friday. Actually, we end up with F is equal to 76. What is F? F is the attendance on Friday. Are we done with our problem? No, you go back to the book and see that what we have asked for, what they're asking us to find, is the total attendance for both performances, not just Saturdays, which was 95, not just Fridays, which we have just now calculated, but the attendance for both days. And of course, that's very simple to find now. You're going to add Saturdays plus Fridays and you're going to see that your total attendance at that play for both days was 171 total attendance. As you spend more time working with these word problems, learning how to analyze them, they'll get a little bit more straightforward to do. I promise you this is not something that you can look at and watch me do the video and you think, oh man, that's easy, I can just go home and now take my test and I'll be fine. No, it really does take practice to do these. Think back to when you learned how to ride a bicycle, when you learned how to play your guitar, when you learned how to grill your favorite steak. You didn't immediately get out there and do it perfectly the first time, even though you watched someone who did it well, you watched someone who made it seem easy. There's what they call a learning curve, and in order to progress up that learning curve to where you're able to solve these problems on your own, it requires practice, okay? Let me show you one more problem. This is one that is a little bit easier, one that's significantly easier, I think. And it'll make you breathe, maybe more normally. But remember, just do your best on these. Text me if you need help. Send me a comment on YouTube. I might be able to get back to you, but your ideal way to get in touch with me is to text me. But let's go ahead and look at this example here, which is problem number 1 in the skill check. It's on page 228. Write an equation and solve. A math teacher discovered that 5/8 of his students made A's on the semester exam. He counted a total of 15 students who made A's. How many students were in his class? So let's see what information we have here. 5/8 of his students made A's. Okay? Write down some extra notes. 5/8 of students made A's. Simple thing to put it down. Okay. Do we know how many students he has? No. Do we know how many A's there are at this point in our problem? No. But we do know that however many he had, 5/8 of them made A's on the semester exam. Now, he counted a total of 15 students who made A's. So 15 students made A's. Now what else do we know? So we know that whatever the total number, 5/8 of the total number of students made A's, so that would be 5/8 of the total. It's going to be 15 students, isn't it? How many students were in his class? We want to find out the total number of students in his class. This is what our unknown is. Total number of students. Total number of students in the class. In this section, they're continuing to use first letter of what you're looking for. So they would say the total number of students is going to be what? Well, let S equal the total number of students. I'm going to revert back to let X because my S's as variables are a problem. Let X equal the total number of students. Is there anything else that we want to represent here? No? There aren't any other unknowns there. So once we've fulfilled our first step, which was assign a variable for what you're looking for, assign a variable for the unknown, the second one says assign any other unknown condition. Make sure that you describe that in terms of the same variable. Well, there aren't any other conditions. The third statement said identify what's equal. What's equal in the problem? Well, 15 or 5/8 of the students made A's. How many students made A's? 15. So 5/8 of the total number of students made A's. And the number of students who made A's was 15. So now we have an equation where we have one thing equal to another thing. And now we can write an equation where we're using variables. What's the total number of our students? The total number of our students we said we're going to represent by x. So I'm going to leave that of there. So 5/8 of the total number of students, or 5/8 of x, is equal to 15. Now we're getting closer to having an equation in algebra here, but we have this pesky little of here. And what are we going to do with that? What does of mean? Of, when you're working and translating algebra to English, that always means multiplication. We're going to always multiply to find a fractional portion of something. Multiply. So instead of using of, we're just going to say 5/8 times x. 5/8 of x. When you have the fraction bumped exactly in front of the variable, it means multiplication. While you could say 5/8 times x, you see here why I just really don't like using x to represent multiplication. But we could say that. We could say 5/8 with a raised dot. 5/8 times x. We could say 5/8, whoops, not 5x, 5/8 times x. Another way of saying it, or you just simply put your 5/8 as the coefficient of the variable. 5/8 x is equal to 15. And this is how you're going to set up your equation that you're solving. We've multiplied x by 5/8. We multiply 5/8 by its reciprocal, which is 8/5. Reciprocals multiply together always equal 1, which is exactly what we're trying to do. We're trying to find the value for 1x. So we multiplied both sides of this equation by the reciprocal of 5/8. And now we can cancel common factors. We see that x is going to be equal to 24 because we have a common factor of 5. 3 times 8 is 24. Are we finished? No. What are we trying to find? We're trying to find the total number of students, so you have to label this. What is the total number of students? We said x was going to be the total number of students. So we have 24 students. Now, our problem is complete. So go ahead and work on your homework exercises. Do the best you can. The more word problems you do, the better you'll get at it. Thank you. I'll see you next time.